At this point, we have the database and the mappings in place, so we are almost done with the persistence for our domain model. If I add a temporary test and write code like this, I should be able to get a snack machine from the database. What I'm doing here is I initialize the session factory with the connection string, create a session, and try to retrieve an entity with ID 1, which I added to the database manually beforehand. As you can tell, this doesn't work. The problem here is that we need to adjust our domain model for the use with the ORM. When we discussed isolation in the first module, I mentioned that although we should try to isolate our domain model from the persistence logic as much as possible, it's not always possible. In many cases, especially when using an ORM, we still need to adapt the domain layer, and there still is some persistence logic leaking into the domain model. Luckily, the degree of the leak is not too big, and the trade-off we are making here is worth it. So how exactly we need to change our domain model in order to use it with the ORM? First of all, nHibernate requires all entities to be unsealed, so we cannot use the sealed keyword here in our snack machine. Secondly, we need to mark all non-private members in the entities as virtual. Also, the setters for the properties cannot be private, so I mark them as protected. And finally, all entities and value objects should have a parameterless constructor. A good news here is that it doesn't have to be public. The snack machine class already has such constructor. The compiler adds it automatically if we don't define it ourselves, but we need to add one to the money value object, like this. And I'm calling it here with this keyword, just to make ReSharper stop indicating it as redundant. You don't have to do this, of course. And we need to make the ID property in the base entity class virtual as well. The reason why these changes are required is because nHibernate creates proxy classes on top of entities and overrides all non-private members in them, so it needs those entities to be unsealed and also have all members marked as virtual. The parameterless constructor is required because nHibernate creates those entities via reflection. The last thing we need to modify is the way we get the type of an entity. Here we check if the two entities we compare are of the same type by calling the getType method. This might cause problems in scenarios with lazy loading. As nHibernate creates proxy classes that inherit from the classes that is being wrapped, the getType method will return the type of the proxy, not the type of the underlying entity. To fix this, we can introduce a getRealType method, which would retrieve the real type of the entity regardless of whether there is a proxy on top of it. It makes use of one of the utility methods in the nHibernate library. Now we just need to replace the getType method invocations. Good, we've solved the problem. That's basically it. The test is passing now, and if we try to debug it and look at the snack machine it returns, you can see there is a single snack machine currently in the database with some money inside, and the test successfully fetches it into memory. As I said, the leak of the persistence logic into the domain logic isn't too big, and we still preserve a lot of isolation for our domain model. For example, we didn't have to change any of the existing tests that validates our domain classes. It is possible to maintain the same high degree of isolation even in larger projects, and you will see how to do it later in this course. Now, as we've set up persistence for our domain model, let's incorporate it into our UI layer. First of all, we need to initialize the session factory. It's a good idea to perform all initialization as close to the startup of your application as possible. This starting point is usually called composition root. In our case, the composition root resides in the app class. It is the class that is instantiated first when the application launches. So let's add a constructor. What we could do here is we could call the session factory init method like this. But I personally prefer to gather all initialization logic in a special class and then use it in the composition root. That way we can enable decoupling between the UI and the utility classes like session factory. Let's add a new class, initer. There would be only one static method, which would call init of session factory. Good. And I can make the class itself static as well. We will add other initialization logic here later in this course. Now we can use this class in the app constructor. I am passing a literal string as the connection string here, but in a real-world application, it should probably be taken from a configuration file. Currently, when main view model creates a snack machine view model, it passes it a new snack machine on each creation. We can replace it with a snack machine taken from the database, fetching the machine from the DB and passing it to the view. Don't worry about the explicit session creation at this point. We will refactor this code in the next module when we'll be talking about repositories. For now, I just want to demonstrate the persistence code in action. If I run the application, you can see the snack machine contains one piece of each coin and node. It means they are successfully taken from the database. The last thing we need to implement is saving the snack machine after a purchase is completed. To do this, we need to go to the view model and persist the snack machine in the bySnack method, creating a session, starting a new transaction, saving the snack machine, and committing the transaction. Note the use of a transaction here. We don't have to use it in this particular case, because there is only a single operation anyway, but it's a good habit to use transactions when mutating data in the database to ensure atomacy of the updates. And again, we will refactor this code in the next module. Our view models definitely shouldn't work with the persistence concerns directly. Let's see if it works. If I insert, for example, 3 cents and click on the buy button, the new amount of money should be persisted in the database. And it is. You can see there are 4 1-cent coins now attached to that snack machine. Perfect, our first draft of the snack machine is ready, and we can move on and build up new functionality on top of it. In this module, we introduced UI and persistence layers for our application. We discussed the MVVM design pattern and where parts model view model belong in the onion architecture. We talked about the importance of finding proper place for the logic we are adding to our codebase. We've discussed the database for the snack machine. We talked about best practices for persistent value objects. They shouldn't have their own tables, but rather be inlined in the parent entities table. You saw how to use an ORM to persist the domain model, and also what changes must be made in order to comply with the in-Hibernate requirements. For example, we had to make the snack machine entity unsealed and mark its non-private methods as virtual. I believe it is still a good trade-off. ORMs free us from a lot of manual work on one hand and allow us to maintain a good degree of isolation for our domain model on the other. We discussed pros and cons of different ID generation strategies. We also looked at mapping strategies and saw what is the best fit for us and why. Finally, we put all pieces together and saw how our domain model is displayed and being persisted in practice. In the next module, we will talk about other two fundamental DDD concepts, aggregates and repositories, and we'll see how to apply them to our project.